Hi, everyone. Welcome to our channel. I'm Aaron. Today, we are going to explore a very important but often overlooked cybersecurity issue: Json injection. In today's digital age, web applications have become an indispensable part of our daily lives. Whether it's social media, online banking, or e-commerce websites, we interact with these applications every day. However, with increased usage, security issues also arise. Json injection is a common security vulnerability that occurs when an application fails to properly handle user input and directly embeds it into JSON data. This vulnerability can allow attackers to tamper with data, leak information, and even perform cross-site scripting attacks. In this video, we will delve into what Json injection is, how it works, and how to protect your application from this threat. We will also show some real-life examples to give you a more intuitive understanding of the seriousness of this issue. If you are interested in cybersecurity or if you are a developer, this video is definitely not to be missed. Make sure you have subscribed to our channel and turned on the notification bell so you won't miss any of our updates. Before formally introducing Json injection, let's first introduce the tools we will use today. Since IWA is developed in Java, we will use Java as the main language for discussing and fixing Json injection. I will use IntelliJ IDEA as the development and modification tool for Java. IntelliJ IDEA is a preferred IDE among many professional developers, offering powerful features and an intuitive interface that allows us to edit code more efficiently. To verify our fixes for Json injection, we will use the security analysis tool Fortify to compare the differences before and after the modifications. Fortify can deeply scan the code to identify potential security vulnerabilities, making it a powerful tool for ensuring code safety. In today's video, we will not only fix Json injection, but also show how hackers exploit this vulnerability to infiltrate systems. I will demonstrate with a simple payload how hackers use Json injection to escalate their privileges, giving you a deeper understanding of this attack method. Finally, we will demonstrate how to effectively fix the code when SSD tools such as Fortify detect Json injection vulnerabilities, ensuring the security of the system. This vulnerability, Json injection, is also one of the topics for the 2024 OpenText seminars in Taiwan and Hong Kong. Therefore, I will use the OpenText example program from the previous video, IWA, short for Insecure Web App, for the introduction. Let's get straight into the video. I used IntelliJ IDEA to introduce and modify this sample program. First, look at the top left corner. This is the project I'm using, IWA. Next, I'll show you where this project is located. To save time, I have already performed a Fortify scan on this project. The scan results file is, by default, located in the target Fortify directory within the project folder. Now, let's open the results file. As you can see, all detected vulnerabilities are listed in the top left corner. The focus of this video is Json injection, so let's open the Json injection vulnerability. You can now see where the Json injection occurs, and by clicking on this node, the central window will navigate to that location. Next, let's go back to IntelliJ and find this location. Before making any changes, I'll show you how the program runs. While running, let's look at line 78, where I added a log. In today's demo, this line will provide more information about the Json. After the program starts, I open the application in a web browser. Once the web application is open, scroll down to the bottom of the home page and look at the input box for subscribing to the newsletter. This is where the Json injection occurs. Before starting, let's clear the logs generated when the program starts to avoid too much noise during testing. Enter any value, such as A, and press the envelope icon. An error appears, proving the program has some validation. Switching to the ID, there is no output in the log. Go back to the browser, enter a normal email address, and press the button. It works successfully. Switching to the ID, you can see the log we added in the program worked, indicating where the program wrote the JSON file. I open File Explorer and opened this JSON file, which contains the normal JSON data and includes the email address we just entered. For the next test, I first clear this JSON file. Then open Command Prompt and use the curl command instead of the web application's UI. After executing the command, go back to the JSON file and see the JSON data is the same as in the previous test. Let's review my initial test. It failed after entering AAA on the web, but what if we use curl command? Back to Notepad++. The program successfully writes to the JSON file, and AA is written in the email JSON note. This proves that the IW application's validation is misplaced, making this field exploitable. Now, moving on to today's main topic, let's create a payload that causes JSON injection. Before starting, we again clear the JSON file. First, I executed the curl command, and what caused the JSON injection problem was the value of the email field in the payload parameter. Returning to the JSON file, this time the email looks fine. But there's an additional role field with the value admin. One can easily imagine how serious this issue could be. I've demonstrated one of the problems caused by JSON injection. Next, I'll show how to fix this vulnerability. First, clear the JSON file to avoid any oversight during the next test. Find the sync point in the initial code. If you only want to fix it to pass the Fortify scan, you can simply use JSON encode, changing the called method from write raw value to write string. Then perform another Fortify scan. If you want to keep the original FPR file, rename it before scanning to avoid overwriting. After the scan, open the FPR file, and you will see that JSON injection no longer appears in the list on the left. However, we can't be sure the modification is entirely safe, so let's run the program again. Bring command prompt to the foreground and open Notepad++ to confirm the JSON file is cleared. Execute the curl command that previously caused JSON injection, and finally, open Notepad++ to see the result. You'll find the issue where the email input added an extra role field no longer occurs, proving JSON encode is effective. But JSON encode might not always be sufficient because, like with cross-site scripting, attackers may combine multiple encoding methods to break JSON encode. Therefore, it's recommended to also add user input validation to provide more comprehensive protection for your program. This video introduces the important vulnerability of JSON injection and demonstrates how to analyze it using the OpenText example program, IWA, step by step. We examine various aspects of the application, from the Fortify scan results to the actual code location, to help you understand how JSON injection occurs and its severity. Through multiple tests, we discovered a validation flaw in the email field of this application and demonstrated how to bypass front-end checks using the curl command to successfully perform a JSON injection attack. These tests revealed that incorrect validation methods can lead to serious security issues. Next, we showed how to fix this vulnerability. By simply using JSON encode, we can effectively prevent JSON injection, but this alone is not sufficient. The video emphasizes that to ensure the security of an application, in addition to using JSON encode, it is also necessary to implement user input validation to provide more comprehensive protection. We hope this video gives you a deeper understanding of JSON injection and that you take appropriate security measures in your daily development to protect your applications from attacks. If you found this video helpful, please like and subscribe to our channel for more content on software security. Feel free to leave any questions or comments below. We'd love to hear your feedback and discuss any topics you'd like us to cover in future videos. Stay secure, and see you in the next video.